All right, let's dive into what might just be the greatest story ever told. Seriously, it's the story of the very beginning of everything, a cosmic origin story that connects every single one of us. We're talking about the Big Bang.
It's a question we've all probably asked ourselves at some point, right? Before the stars, before planets, before any of us. What was there? How did this unbelievably vast and incredible cosmos even come to be? It's the ultimate cosmic mystery.
Well, the answer science has for us is a theory so big, so mind-bending, it completely changes how you see your place in the universe. It's the Big Bang Theory, and it is, without a doubt, the most epic origin story of all.
So our story has to start at the absolute beginning. And I don't just mean the beginning of planets and stars, I mean the beginning of space and time itself. Let's wind the clock back, way back. We're talking about 13.8 billion years ago. Just try to wrap your head around that number for a second. That's how old our universe is. So what was there right at time zero? The theory points to something called a singularity. Now this is where things get really weird. Imagine everything, all the energy, all the matter, all the potential for every galaxy and star crushed down into a single point. A point smaller than an atom, hotter and denser than you can possibly imagine. That was the starting line for our entire universe.
Now here's something really important to get straight. The name Big Bang is a little bit misleading. It makes you picture a huge firework going off in some empty black void, right? But that's not what happened. It wasn't an explosion in space. It was the rapid expansion of space itself. Every single point started rushing away from every other point. And the craziest part? It's still happening right now.
Okay, so from that single tiny point, the universe burst open and started to cool. But what happened in those first critical moments? The timeline is just unbelievably fast.
The early universe was just a whirlwind of change. We're going to look at 4 key milestones that took it from that hot, dense soup to the beginnings of the cosmos we know and love today.
In the very first fractions of a second, the universe was just this chaotic frenzy of pure energy. We're talking trillions of degrees hot. It was so intense that matter, like atoms, couldn't even hold together. All that existed was this sea of fundamental particles, things like quarks and electrons, the absolute basic building blocks of everything.
So from that initial hot mess, the universe expanded and began to cool down. After just a few minutes, it was cool enough for the first simple atoms, like hydrogen and helium, to form. But for the next 380,000 years, the cosmos was this dense, glowing fog. You couldn't see through it. Then, a crucial moment arrived. It cooled just enough for light to finally break free. Suddenly, the universe became transparent. From there, gravity was the new boss, pulling these huge clouds of atoms together, until, millions of years later, the pressure became so immense that, poof, the very first stars and galaxies ignited.
Now, this is an amazing story, but I get it. It sounds a bit like science fiction. So how can we possibly be so sure about things that happened billions of years ago? It's because the universe left clues behind, and scientists have turned into incredible cosmic detectives.
This is the most important question in all of science, right? A theory is only as good as its evidence. So let's actually look at the hard data, the clues that make the Big Bang the leading explanation for where our universe came from.
Scientists have pieced this puzzle together using 3 main lines of evidence. We're going to look at the expansion we can literally see happening, an ancient glow that fills all of space, and the chemical recipe of the cosmos.
So clue number 1 is happening right now, above our heads. When astronomers like Edwin Hubble looked out at distant galaxies, they found that almost all of them are moving away from us. And the farther away a galaxy is, the faster it's speeding away. This is the smoking gun. It's exactly what you'd expect to see if the entire fabric of space has been stretching since the very beginning.
The second clue is just so cool. It's like an echo of the past. It's called the cosmic microwave background. It's this faint glow of radiation that comes from every single direction in the sky. It's not from any star or galaxy. It's the leftover heat from the Big Bang itself, the afterglow from that moment the universe became transparent. It's like a perfect fingerprint of that incredibly hot, dense beginning.
And for our third clue, we just look at the universe's ingredients. The Big Bang Theory predicts exactly how much hydrogen and helium should have been created in those first few minutes. And what do you know? When we measure the amounts of these elements in the oldest stars, the numbers match the predictions almost perfectly. It's just a stunning confirmation of the theory. So these clues give us incredible confidence in the Big Bang model. But the story is far from over. In fact, everything we've learned has just opened up even deeper, more profound mysteries. The investigation is absolutely still on.
This is probably the biggest question of all. The Big Bang Theory does a brilliant job explaining what happened after that first moment. But it doesn't explain the trigger. What caused that first singularity to start expanding? Right now, that is a profound mystery.
And that question leads to an even more mind-bending one. If time and space literally began with the Big Bang, does it even make sense to ask what came before it? Was there anything? This is the absolute frontier of theoretical physics.
And if that's not enough to keep you up at night, our observations show that everything we can see, all the stars, planets, and galaxies, makes up only about 5% of the universe. The other 95% is made of two invisible components: dark matter, which is like a cosmic glue whose gravity holds galaxies together, and dark energy, an even stranger force that's making the universe expand faster and faster. That's right, 95% of our universe is still a complete mystery.
So why does a story that started 13.8 billion years ago even matter to us today? Because it's not just the universe's story, it's our story too.
Every single atom in your body, with the exception of hydrogen, was forged inside of stars that would not exist without the Big Bang. The iron in your blood, the calcium in your bones, it is all, quite literally, stardust, born from that initial cosmic expansion. This is the ultimate shared origin story for all of us.
The investigation into our cosmic origins is one of the greatest adventures in human history. We learned so much, but the biggest mysteries, dark matter, dark energy, the origin of the Bang itself, they're still out there, waiting for the next generation of thinkers, dreamers, and detectives. And who knows, maybe you'll be one of them. Keep looking up.